All right, so interrupt 10 is actually used to clear the screen. And then next, we can also set the cursor position. Let's say we have a cursor, okay, on our screen. So where we want to set that cursor to be, right? And then also, I'm going to, we can also use to write characters to the screen in the text mode, okay? And we can also draw lines on the screen in graphic modes, okay? And also change the video mode, okay? And then otherwise, so we have INT21 page, all right? That one is used to characters from the keyboard, okay? And output the characters on to the screen, or input or output the strings, okay? So we will, so basically this is what you will learn in this topic. Okay, so the INT instruction is somewhat like a bar call, all right? So it is actually, we save the CS, okay, CS register, and instruction pointer, okay, IP, and the flags on the stack, and goes to the subroutine associated with the interrupt. Okay, so in 86 processor, we have 256 interrupts, okay, which is from 00 to FF, okay. So basically, INT10 is part of that, and also INT10, also INT21 is actually the one that are most widely used in various functions selected by the value in the AH register. Okay, and the interrupt 10 subroutine is actually already burned into the ROM, okay, into the ROM of the CPU. Okay, so it is used to communicate with the computer screen video, okay, and actually try to manipulate the screen text graphics, okay. So we can use that INT10 as I mentioned on the first slide just now. Okay, among the functions associated with the INT10 are the changing character or background color, clearing the screen, and changing the location of the cursor. Okay, so this is actually chosen by putting a specific value in the register AH. Okay, for example, like this one, right? So this is the monitor screen in 86 PC. Okay, we can divide that into 80 columns, okay, 80 columns and 20 rows. So basically you can imagine like this. So we have, okay, we have 80 columns, all right? So from 00 up to 79, okay, so that's the columns available, okay, on the 86 PC. And the rows, okay, the rows that you have is actually also from 0, okay, up to 24, okay. So which is you have, okay, here you have 80 columns and you have 25 rows, okay. Okay, top one, the top row, okay, so that is associated, okay, with 0000, okay, the top left corner, and then the top right corner is 00,79, okay, and the bottom left corner is 24,00, and we have on the right one is 24,79. Okay, so that is in terms of a decimal. All right, that is in terms of a decimal. But if it is in terms of hex, then this will be the number. Okay, so over here is 4F, and then we have over here we have 18, right? And then okay, so that's the difference. Okay, so that is for the decimal assignment on the normal text mode. Okay, and then this is in terms of hex assignment, right? Okay, so normally, so we use the decimal, okay, the decimal mode, all right? So this is just for the reference for the hex. Okay, so clear the screen using the INT1. So basically, if we already have something on the screen and then we want to clear that, so we need to assign the registers with certain value. Okay. All right. So this actually the steps is like this. So we need to assign AH with 06. Okay. AL as 00, BH as 07. Okay, and CX as 0000, and DH 24 and DL 79. Okay, so you look that over here. Okay, so DH, okay, that actually mentions about the number, the rows, okay, the rows, okay, and then we have DL, which is related to the number of columns, okay. So over here, so this is how clearing the screen is done. So first, the 06 is moved to AH, okay, and then AL is assigned with the 00, and BH is assigned with 07. Okay, so basically because of the CX, so CX you assign that with the CH as a 00. So basically this is basically divide 4. Okay, so CH is column number, all right, and then the ending is DL. Okay, the ending is DL. Okay, sorry, the CH is for row, and then CL is for column. Okay, so CL is paired with DL, and then CH is paired with DH. Okay, and then after that, so once you did this command, and then you type int10. Okay, so once you did that, so the screen is clear. Okay. Okay, and then we have okay, in order to change the position of the cursor, right? So let's say my cursor on the screen. So let's say we want to have a starting point where the cursor should be. Okay, so we change that on the AH. All right. So the position, okay, actually is identified by the row or column in the DL and DH. Okay, so it is like the one as before. Okay, so that function we use as AH02. AH02. Okay, so for video a random access memory, okay, can have multiple pages of text. Okay, when we set AH is 0, the page 0 is by making BH as 0, 0. Okay, this is in the case if we use video RAM, okay, or video random access memory. So we need to mention that what page that we want to what page that we're going to locate the cursor. Okay, so let's say on the page is 0, so we need to specify that BH equals to 0, 0. Okay, so after the command, okay, after the instruction of int, okay, 10 or int 21, okay, so registers that is not used by interrupt remain unchanged. Okay, so this is example on how we can set, okay, the cursor to a specific location. Okay, so for example, you want to have this, all right, at the row 15, also the column 25. Okay, so of course we start with setting AH equals to 2, all right, and then let's say we are using the video RAM, okay, so we need to specify BH as a 0, 0, and then we specify the column position DL is 25 and DH 15, okay, and then invoke the interrupt int 10. Okay, so that's how you set the cursor position to be at row 15. So to be at row 15 and column 25. Okay, so somewhere around, for example. Okay, in the text mode, okay, so we're going to determine where the cursor is located by executing this following. Okay, so over here, before this we use a 0. Okay, so that's basically the first setting. Okay, first setting. Okay, where we want to set the cursor. But if the cursor, but right now, if in the text mode, all right, so we set the AH equals to 3. Okay, AH, and then we set the page number, right? So the page is still 0, 0, and then we invoke the interrupt. And then, so basically, so we are trying to know, okay, where is current cursor location? Okay, so before that, we want to mention, okay, at which location AH2 we mention at which location is the cursor, all right? When we write AH03, we are trying to find the location of the cursor, okay? Okay, so we will get the information of DH and also DL, right? Okay, so we also have the register. The function is to show you the shape of the cursor, right? The shape of the cursor. So how would it be? It is an arrow, okay, the white arrow or the black arrow, okay? So that CX determines that. Okay, so that in terms of we want to get the current cursor position. So we already learned, okay, before that. So we want to clear the screen. So we know what is the instruction, okay? There is AH06, okay, we start with AH06, okay? Okay, and then for mentioning the cursor, so we use the command of AH02, okay, and also 03, okay, like this one. and then we want to change the video. Okay. Okay, so to change the video, okay, so we set the AH as 00 and AL equals to the video mode. Is equals to video mode. Okay. So let's say we have in the monochrome monitor. Okay. So we have the attributes. Okay. So these attributes is actually we define that with a specific character to mention about what is actually on the video, right? So basically, we want to mention that what is the background color, right? Intensity, and also about the character that is typed, okay, on the screen. Okay. But for the monochrome monitor, it is limited. Okay, so this is the attributes. So we from D0 up to D7. Okay. Okay, so in the foreground, okay, we okay, at D3, it is for intensity. Okay, if it is 0, it is normal intensity, and if it is 1, it is highlighted intensity. Okay, for D4 up to D6, okay, it is for the background intensity. Okay, and then for D7, it is whether we are measuring that character, okay, is blinking or not blinking. Okay, and then we D0 to D2 actually mentioning about the character. Okay, so character display is actually shown, okay, by the attributes of D0 to D2. Okay, so this is example in the text. Okay, so I won't go through this one. All right, so let's have a look to the CGA. Okay, we have, okay, now we have the color monitor. All right, so we have C, which is the color uh, attributes. Okay, so now we have RGB. Okay, in the modes of RGB. Okay, so RGB is still used up to today. Okay, so we have as all color monitors and videos screen are upwardly compatible. Okay, so we have, this is the attributes of the CGA. Okay, so we have, okay, D0 up to D12. Okay, and then like the monochrome monitor, we have D7 for blinking. Okay, and D3, D4. So we have the, and then we have, okay, this is for the RGB. Okay, so we know that this is the RGB combination. Okay, so we have D4 to D6, and so D0 to, okay, so the background, so this one, this background, okay, that can be up to 8 different colors. Okay, so by combining the prime colors, red, blue, and green. Okay, Okay, for example, we look over here. Okay, we want to write a program that number 20, okay, on the entire screen, and then we want to use the high intensity white on a blue background character. Okay, first of all, as I mentioned before, so we need to choose the video mode, right? Like this one. Okay, so first you need to change the video, so you need to set AH and AL. So AH will be 0, and then this is the video mode. Okay, okay, this is the video mode. Okay, so now your video mode is CGA color. Okay, text mode of 80 times 25. Okay, and then you invoke the interrupt. Okay, interrupt 10, and then you have the display option, which is AH09. Okay, and then what you have is you set the page 0, so it's still page 0, and then you set AL, okay, AL as 20. Okay, so this is for space. Okay, S key space. All right, so you AL as 20H. Okay, so that one, and then you have, okay, so now the CX. Okay, so you put that CX, so you actually you have that space, S key space, so you want a blue background. Okay, actually you have that space. Okay, so you have that space. Okay, so this is one, you have the space. Okay, so you did that how many times? Okay, for 800 times. Okay, meaning that if you did that for 800 times, okay, so you have actually you have 8 rows, okay, actually filled, 8 rows filled with the color, right? So now you have high intensity white on the blue, right? So basically the eight rows, okay, that full 8 rows will be white, the rest will be blue. Okay, so that's how you set, okay, the characters intensity on the background color. So this is the possible color that we can have. So this is the RGB. Okay, so for example, this is actually what will happen. Okay, so all zeros are black. Then for very high intensity white, so we have all of that as 1. Okay, and then okay, so we look over here. Okay, so this is the effect. So we can actually, okay, this is actually for every 4 bit. Okay, we can set 4 bit on the upper bit and also 4 bit on the left bit, the lower bit. So we can have the two colors, right? 2 colors on the screen. Okay. So basically, you have the characters, okay, on the foreground, and then in the background, so you have another color. Okay. Okay, so this is what happened. Okay, so we have, so the code is a similar, right? So let's say you look, so over here, this one 0001 is green. Okay, so 001 is green. Okay, so this is on the top one. Okay, is the one that is on the foreground, and then on the lower bit, okay, this one is sorry, on the lower bit, it is actually on the foreground. On the upper bit, okay, on the upper bit, it is actually on the background. Okay, so this is on the background, and then this is on the foreground. Okay, so okay, this one is green. Okay, and then this one is blue. Okay, so this one is blue on black. Okay, so on the foreground is blue, at the background it is black. Okay, and then this is red. Okay, this is blue. Okay, and what is high intensity white on the blue. Okay, blue is on. Okay, so that was in the video modes. Okay, in the video mode. Okay, in the text mode, okay, the screen is viewed as a matrix of rows and columns of characters. Okay, in the graphic modes, it is actually in terms of pixel. Okay, so the number of pixels depends on monitor resolution and also the video board. Okay, there are two facts associated with every pixel on the screen that must be stored in the video RAM. Okay, so first is the location of the pixel. Okay, and the attributes. Okay, which defines the intensity of the color and also the color itself. Right. So the higher pixel and colors, the larger the amount of memory that is needed. Okay, so if the requirements goes up, so actually we need to have a bigger memory to store more colors. So the CGA mode, okay, can have a maximum of 16 kilobytes of video memory due to its design structure. Okay. Okay, so for the text, actually we follows the one that I mentioned in the first slide. So we have 80 columns and 25 rows. Okay, so basically, if you multiply this, you can have up to 2,000 characters. Okay, and then plus 1,000 of attributes. Okay, because each character that you type on the screen will have one attribute byte. Okay, so total of that, so you have 4K. Okay? So for each screen frame, okay, so this is what is supported by the CGA mode. Okay, and then this is actually, it supports up to 4 pages of data, right? Where each page represents one full screen. Okay, as previously, in this mode, 16 colors are supported. Okay, so you notice that. So 16 colors are supported. Okay, to select this mode, okay, so AL03 for mode selection in interrupt 10. Okay, option AH00. Okay, so when option AH00 and then we use AL3, okay, so we use the CGA mode. Okay, the graphic modes, as mentioned before, it actually depends on the video RAM capacity. Okay, so it can be, okay, it can be at this size, okay, 320 times 200, okay. So this is called as medium resolution. So when you times these two numbers, so it gives you, okay, 64K, okay, 64K of pixels, right? Okay, so basically, if you have video RAM of 128 bits, right? So meaning that you have that 16K, okay, uh, K times 8 bit, okay. So you get 128K, okay. And then by 64K pixels, give 2 bits of the color for each pixel, okay. So meaning that half of that, okay, because 64K is half of 120K bit video RAM. Okay, so each pixel will give 2 bits for the color of each pixel. Okay, so for 2 bits, it gives 4 possibilities. Okay, so therefore we have support of the CGA up to 4 colors, right? So in order to select this mode, we use ALS04. And then we also have 64 times 200. Okay? This is more modern resolution. So we have, during that time, we call that this is a high resolution. Okay, 640 times 200. Okay, so 200 times 240, so we obtain 128K pixel. Okay, so 128, so we have, okay, 1, okay, when we divide with that, so 1 bit for color, and then which can be on white or off, okay, which can be on or off, okay. So that's the number of, okay, so the number of bit for every color. Okay, so because of that, so this 640 times 200 high resolution CGA can support only black and white. Okay, so to use this, we set AL as 06. Okay, so before that, if we want to use 320 times 200, we use AL as 04. Okay, so with a fixed amount of video RAM, the number of supported colors decreases as resolution increases. We need to have more video memory in order to have more colors, right? Because when we increase the resolution, right, that we have up to 640 columns and 200 rows, so mean that the pixels are now very small on the screen. Okay, so when we have more pixels, actually it gives us a sharper view, right? It gives a sharper view. Okay, but the drawback of that, if we don't increase the amount of video RAM, then the number of colors that can be supported by that actually is reduced. So that's why actually when you see that we have increased video resolution, then we have the supporting color of black and white only. All right, when we don't increase the video RAM uh, value. So we need to increase the RAM in order to have a multiple colors to be shown. Okay, to address a single pixel on the screen, we use interrupt 10 with AH0C. Okay, so meaning that if you want to know, right? So actually, pixel that you want to select. Okay, so we use this command. All right, AH0C. Okay, and then the the column. All right, the specific column and the coordinates of the pixel must be known. Okay, and then the registers. So we put the CH, right, and also CX and also DX. So we need to specify that. Okay, so why we use CX and why we use DX, right? Because we have, when we have multiple resolution, let's say up to 600 640 times 200, so we need to have the 16-bit register, okay, rather than, so sorry, we need to use the 8-bit register, okay, rather than just use the 4-bit register, okay, which is not enough to for you to mention the location of uh, the, the pixel, right? But if the pixel, okay, can be mentioned by just the, all right, by just the 4-bit register, then you can just go with the 4-bit register. Okay, so to turn the pixel on or off, okay, so mean that for the pixel you can actually make it black or white. Okay, so if you want to make it black, so you put 1, okay, AL as 1, and if you want to make it uh, if you want to make it white, so you put AL as 0. Okay, and the value of AL, okay, can be modified for multiple colors, right? Okay, if the display mode supports more than one page, okay, so we manipulate the BH, right? So we change the BH value to specify which page number that we are working on. Okay, so another function of INTH programming, we can also draw the lines. Okay, so this is the fourth function. Okay, it can use to draw a line. Okay, to draw a horizontal line, we choose row or column values to point to the beginning of the line and increment the column until it reaches the end of the line. And then to draw a vertical line, okay, increment the vertical value by the dx register and keep cx constant. Okay, so cx constant value, and then we keep increase the dx value. Okay, so we can have how many dx, and then that determines how long is our vertical line. Okay, so we use the linear equation y equals to mx plus b to draw the line. Okay, so this is one example on how to draw the line. Okay, first we want to clear the screen. Okay, so as you still remember, so to clear the screen, okay, we set AH as a 06, all right, and B set as a 07, okay, and CX we specify from 00 up to 00, okay, and then, okay, so we look for the mode, all right, CG, you want to have it at 640 times 200 resolution, and we want to draw a horizontal line starting at column 100 and row 50, okay, ending at column 200 and row 50, okay, meaning that it is on the same row, so it will be a horizontal line. So but it will start from the column 100 up to column 200, so it is actually at the middle of the screen. So actually that depends on the resolution of your screen, so which is 640 in terms of column. So 100 to 200 is actually at the middle of that. Okay, it's actually a little bit left. Okay, a little bit left. Okay. All right. So you move dx. Okay. Okay, you move dx to row 1. Okay, 1h and 4h. All right. So this is actually to clear the screen. Okay. So this is actually to clear the screen. Okay, why we use dx over here as a for f? Okay, because see at the first screen and the first slide that I showed, so it is actually that's the maximum number of column and number of and also column. Okay, so basically you state cx from 00 up to the dx. So you want to clear all of that all of other information on that screen. So you want to clear that. So you mention that cx. Okay, type the interrupt int10. So once you have that, okay, so you set the mode, okay, ah00, okay, and then use the CGA, which is AL, okay, 06, okay, and then interrupt, okay, change the mode 10, okay, and then you want to go to the line of 100 and row 50, okay, so put that into CX and also DX, okay, and then that instruction, okay, so which is 0C, okay, which is 0C, you want to draw the line, okay, and also you state that the pixels are what, okay, so because you mentioned that as one over here, so you put that into the AL, okay, and then invoke the interrupt, okay, so that is done, okay, and then you increment the CX, okay, this is your starting CX, and you should stop until it is 200, okay, so this is repeated, okay, this repeated, okay, so it is compared. If the CX over here is not 0, sorry, it's not 200, then this instruction repeated until CX value is 200, then you have the jump, you have the 0 value, okay, you have the 0 value, then it will not, it will jump, okay, so because, sorry, until this will give you 1, okay, so because whenever jump non-zero, okay, jump non-zero, okay, if non-zero, then it will jump, okay, it will go, okay, it will go to back. But if it is 0, okay, if this is 0, meaning that the instruction is not executed, okay, it will go to back, okay, so you will do the loop of back, okay, and then do it again and again and again. Okay. So that's how you draw the line, okay. All right, so let's take a break for 10 to 15 minutes, right? So before we continue with interrupt 21, okay, any questions so far? So that's actually the four things, all right, the four application that we can use with the INT10. Okay, INT10, first to play, then next we set the cursor position, and then we change the video mode, right? Either we want to set it or color, right? And the last one we want to draw the line. Okay, so that is related with the interrupt 10. Okay, so if there's no question, then let's have a break for. Yes, you have a question?
Uh, the how to say, how can we know what is the operand that we need to use of, and use interrupt. I mean, we need to invoke the function. There is a lot of like color here. How
Okay,
can we?
all right. So look over here, right? So there is actually different assignment to the register. Okay, different assignment to the register that actually uh, specific operand for that. Okay, so let's say, okay, so you want to draw the line. So you put you set AH as 0C. Okay, so that's for drawing the line. Okay, for setting the video mode. Okay, so your okay, so you set over here AL as 04. Okay, but AH what you set is 00. Okay, so you set AH is 0 and you put 04, then it will change to the video mode, or 03. Okay, or AL as 03, then it will change to the color mode, right? CGA. So that's for video mode. Okay, so for clearing, for okay, so for clearing that, okay, we set, sorry, this is for cursor position. For cursor position, we set AH as 03. Okay, so you see the difference there. And for the clearing the screen, so we set AH as 06. Okay, AH is 06 and AL as 00. Okay, so basically there are different combination of AL and AH where you can set for different types of application that you want to use. Okay, so you just need to remember what value of you should put to AH and AL to do that kind of application, right? Okay, any other question? Then let's have a break for for 10 to 15 minutes. So we'll see you around for 10 to 4:15, something like that. Okay. Okay, we're back. Uh, right, so before going further to the Interrupt 21, so how about having a quick quiz, right? So you guys can join on this quiz. I'll just share the screen. Okay, so you guys join the quiz over here, right? So take your time. So look whether you already understand what is. So we have 5 questions over here. Okay. So whether you already have a quick understanding on about interrupt 10H. Are you guys there?
Yes, Doctor.
Okay.
Ada, Doktor.
Because I don't see anyone is yet. All right. Okay. So we got the first participant.
Do I need to put matrix or?
Just put your real name. Okay.
Okay.
Okay. I'm gonna wait for another 1 minute. All right. Before we start. Okay. So right, we have 27. All right. I think we can start now. Let's start. Yeah, the person are too slow. 1, 2, 3. Okay, I'm going to stop now, right? So we just review back to the questions. Okay, congrats for those top 3. Okay. Okay, right. So basically for this one, okay. So interrupt 10H, all right? So of course, perform screen input and output. Okay. All right. So this one. So many of you got it wrong. Okay. So what should it be? It is actually 80 and 25, right? 80 and 25. Okay, for this one, so green, okay, and foreground white blinking. Okay. So what's the code? So we have 4 and 4, right? So you remember that for the background, okay, so the background should display on the on the upper bit, right? On the upper bit, okay. So you should have that as D, right? D. So D is the answer. Okay, so for this one, this is for indicate the cursor location. All right. Okay, so for this one, I apologize because I missed one CL over here. So that answer should be should be seven numbers should be there, but actually the columns there is only 6. All right. So let's neglect this question. All right. Let's neglect this question. Okay. So congrats for those who, there are many of you who got, most of you, yeah, I think 4 of you got 100% correct. Okay, and actually that's the last question, right? The last question that many of you got it wrong, that it should be fine. So but let's see here, still some of you got it not correct for the first 4 questions. Okay. So congrats for those who got the top 5, right? So for those top 5, you will get a bonus mark later, all right? For those who haven't got chance to do that, you're going to have more chance after this, right? I'm gonna give you another set of quiz, right? Maybe on Thursday class or next week Tuesday class. So just be prepared. Okay, so for now, let's continue with a little bit with interrupt 21. Okay, so right, in the interrupt 10, okay, So that data was defined as a memory dump. Okay, we cannot, uh, we cannot give the input, right? So it is just, we just see it, all right? We just see it, okay? But for interrupt 21, okay, so we actually can input from the keyboard, okay, and then display it on the screen, okay? So it is much more dynamic way of processing information. So when the operating system is loaded, the interrupt 21 can be invoked to perform some extremely useful function, okay? So this is called as DOS interrupt 21 function call, okay? So this is in DOS. So but for the interrupt 10, it is actually in the BIOS. So where we already pre-configured the instruction, okay, to do what should be done, okay, by the CPU. Okay, the interrupt 21 can send a set of ASCII data to the monitor, right? So we set, okay, in here we set AH equals to 09 and DX, the offset address of the ASCII data. Okay, so over here we can display the ASCII data string pointed at by the DX, okay, until it counters the $sign. Okay, for example, like this one, okay, we want to display the message of the Earth is but one country. Okay, so you will see that you will have the $sign. Okay, so once you see the $sign, okay, so it will stop there. Okay, so for example over there, so we put the, so we set the AH as 09, okay, and then we offset, okay, the data in ASC, which is our string, okay, which is our string over here, and then we put interrupt 21. Okay, so it will display the Earth is but one country. Okay, so the message is displayed. Okay, to output only a single character, okay, 02 is put in the AH and DL is loaded with the character to be displayed. Okay, let's say we want to display the letter J. Okay, so because it's just one character, which is J, so we put the we set AH is 02, and then J, okay, we put string J into the DL, okay, and then we invoke the interrupt int 21. Okay, so this option can also be used to display the $sign, okay, on the monitor, as the string display option 09 will not display $. Okay, so before this 09 won't show this $sign. Okay, but if you use uh, 02, it will display with this $sign. Okay, but it just show you a single character. Okay, okay, we can also input a single character with echo. So what does this mean? Okay, this means that this function waits until a character is input from the keyboard. Okay, then it echoes to the monitor. Right. So actually, it waits from the input. When we type, actually it waits us to type character. Okay, then it will show what is on the monitor. Okay, so let's say we input one character, okay, and then we just straightly put the interrupt 21. So remember that. So for echoing the character, so we set AH as 01. Okay, and actually interrupt 10 and interrupt 21 can be combined. Okay, so it can be combined. So, but the function is similar. So if we want to key in something from the keyboard, we need to invoke the interrupt 21. But if the function is already on the CPU, so we just use invoke interrupt 10. Okay, so we have interrupt with option 0A. Okay, so what does that mean? So we set the register as 0AH as 0A, and then it actually we can get the data, okay, from the keyboard and then store that in the predefined data segment memory area. Okay, so we store that, okay, when we put as AH as 0A. Okay, so this is called, when we store the information, we call that as a buffer area. Okay, so this operating system, the DOS, requires a buffer area to be defined in the data segment. Okay, the first byte specifies the size of the buffer, and then the number of the characters from the keyboard is in the second byte. And the key in data placed in the buffer starts at the third byte. Okay, for example, for this one, okay, so this program accepts up to 6 characters from the keyboard, okay, including the return key. Okay. Okay, so over here we have 6 buffer locations were reserved and filled with FF. Right. So over here, first we set 0A to a hash, and then we need to input the data one, right? The data one is this one. Okay. So we need to load, okay, the offset, okay, at the data from the location of 012, okay, 012 to 0012 to 0017 with the FF data, right? With the FF data. Okay, so once we call that, all right, so we move into that DX, okay, and then we set the interrupt 21. Okay, so basically what is seen, right, what is seen over here. So as before this, you mentioned that it starts at 0010H. We set the buffer, okay, how many FF that we want to store, okay, so that the size of buffer, so we need to set 6. Okay, so we store FFF up to 6. All right, and then we have at 0010, and then at 0011, so which is mentioned here, is the number of characters from the keyboard. Okay, number of characters from the keyboard is in the second byte. Okay, so but now over here, we don't have any numbers from the keyboard, right? So it is set as 00. Okay, if there is number of characters, then whatever we type the number of characters, then it will be shown at the location of 0011. And the location of 0012 up to 0017, which is 6 of those buffer locations, so we fill that in with the FF. Okay, so all of those are filled with the FF. Okay, let's say we entered the data, all right? So now, before that, we didn't key in the data, so it is 00, all right? Now we type in with USA, all right? So we have 3 characters over here, U, S, and A, okay? So now we have 00, it will become, okay, starting from 00, okay, and now it becomes U, it becomes 201, and S becomes 02, and A becomes 03, okay? And then it will change, okay? It will change the content, okay, to show the character of USA, okay? USA, and then this is U55, SA, right? USA. And then we have a return, we have a space. So space is 0D, okay? So space is also included. Okay, and the rest will still remain with the information that we stored before, FF and FF. Okay. So this is what this display is, USA CR. Okay. Carry return. Okay, so this is 0D, which is the return. Okay, so this is the information. Okay. Carriage return. All right, 0D. Okay, but if we enter more than 6 characters, okay, 5 plus the carriage return, so it is will cause the computer will sound the speaker. So will sound the beep beep beep. All right. So it is actually we can put only up to 5 characters plus the return. Okay. Okay, so we have the location of that, all right, as 0015. Okay, so if we enter more information, okay, so the location for that we fill in with the, let's say we fill in the A, all right, and then we put the space. Okay, USA space A, all right, USA space A, and then we return. Okay, so that the line is 05. Okay, because it depends on the number of characters that we put. Okay, so space is also included. Okay, if only the character return key is activated and no other character, okay, so the 0A is placed. So the 0A that we initiate at the AH, okay, is placed in the memory of 0020, okay, and then 0021 is for the counting. Okay, for example, over here, so we have 0A at location of 0020, and 21 is for the counting, okay, increment of what we enter after that from the keyboard. Let's say we enter USA and so on, and 0022 is the carriage return, okay, the carriage return, and then others, right? Other than that is the information that we fill in, we stored before. Okay. All right. So this is because actually we already pressed the return key. Okay. So that's why the information of 0022 becomes 0D. Okay. Okay, so this is actually example in the book, which is program 4.2. Right, so there is also program 4.3, also program 4.4. Okay. All right. Okay, we stop here for today. Okay, so remember that your test 2 will be next Thursday. All right. Will be next Thursday, and I'm going to, yeah, hopefully by today I'm going to finish uploading you with the set of practice, okay, problems with given answers, so you can do the practice on that, so as preparation for your test 2. And then we will finish this chapter 4 by Thursday, and then your test 2 will be up to this chapter. Okay, and then next week we're going to continue with a new chapter. All right, any questions so far?
No, Doktor. Tak ada, Doktor.
Okay, so let's turn on your camera so we can take the attendance for today. Right. I'm going to count from 10. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, thank you everyone. Okay, have a nice day. Okay, Assalamualaikum and bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
You're welcome. Thank you.
Thank you, Doctor.
You're welcome.